Bismillah ar-Rahman rahim. In the name of Allah, the most merciful and the beneficent. I am Muhammad Gasaza and I am going to deliver lecture number 7 of chapter number 1, Measurements. Today our topic is dimensions. This question is very important according to the federal board paper point of view in the form of a subjective as well as in objective and in numerical problems. Well, first of all, what is dimension or what are dimensions? Step number one is definition. The power of positive or a negative to which the fundamental units of the first system must be raised to the unit of a given physical quantities. These physical quantities might be derived quantities or derived units called dimensions of physical quantities, or in a simple way, a representation of a physical quantities which are based on a mass, length and time with the capital letter M, L and T in a square brackets. So basic dimensions are length, width, depth, radius, distance, height, radius. Dimension is basically represented by capital letter L, which is written in a square brackets as we seen here. So similarly, mass dimension is M, capital M, and time dimension is capital T. These dimensions are represented in square brackets. These dimensions are solved by formula, and in next slide we solve different dimensions of different quantities. In next slide, for example, dimensions are given as displacement dimension is represented by L, so it is written in capital letter L and between square brackets, as well as mass dimension is capital M and time dimension is capital T. These dimensions are written in a square bracket. Second one is area. So area formula is length multiplied by width. So length is also represented by L and width is also represented by particular length L. So L multiplied by L square. So dimension of area is L square and square bracket. Second one, fifth one, volume. Volume is represented by formula length multiplied by width multiplied by height. I already explained it that height is also represented in the form of a length, and its dimension is L. So length dimension is L, width dimension is L, and height dimension is L. So L multiplied by L multiplied by L becomes equal to L cube dimension. And so here volume dimension is capital L in square bracket cube. Sixth is a density. The density formula is a mass per unit volume, and as we know about the dimension of a mass and a volume, so it becomes ml inverse cube and the square bracket. Seventh one is a velocity. The velocity formula is the distance over time. The distance or a displacement dimension is capital L and time is a t. This t becomes t inverse, so lt inverse square bracket. This is the dimension of velocity as well as acceleration is equal to velocity over time. Now I put here dimension of a velocity lt inverse over time t. This t becomes lt inverse square. This is dimension of acceleration. Linear momentum, according to the linear momentum formula, mass multiplied by velocity, so m multiplied by v. Well, velocity dimension is lt inverse. This becomes mlt inverse. 10th one is of force. So force dimension is calculated by second law of motion. F is equal to ma. M is a mass, a is the acceleration, mass dimension is m, and a dimension is capital. Capital lt inverse square, which we already sort out, and when combine these we get mlt inverse square. Next one is the impulse. Basically impulse is a product of a force multiplied by short interval of time, so it is represented by J. And impulse is a large force applied on a body within a short interval of time, so its formula is F multiplied by T. As we calculated force dimension, that is equal to mlt inverse square, and the dimension of a t, it becomes mlt inverse. Next one is a pressure, and its formula is a force per unit area. Force dimension is mlt inverse square, and area is equal to L square. So by cutting these we get ML inverse T inverse square. In next slide, so in dimension number 13 we will deal with work done according to the formula of work done, F dot D. Putting the dimension of a force here, MLT inverse here, and the dimension of a displacement L. So we get a work done dimension that is equal to ML square T inverse square. Energy is also equal to work done, so its dimension is the same, ML square T inverse square. But we can also sort out it with the help of a Einstein famous paradox equation, E is equal to mc square. According to Einstein paradox equation, so m is a mass and a c square is a speed of a light. So speed of a light is equal to v, and we get the and dimension in such a way that mass dimension is m and c square dimension is L square T inverse square, that is also equal to velocity square. So by combining these we get ML square T inverse square, which is equal to work done. Now in dimension number 15 we will talk about moment of inertia. According to moment of inertia, the basic formula is equal to I is equal to mr square. M is a mass of a body and r is the radius. So r dimension is L and r square means L square. So this becomes I is equal to ml square. In number 16 we will talk about torque. According to the formula of torque, tau is equal to r multiplied by f. Dimension of r is equal to L, and dimension of force is equal to ml T inverse square. By combining these we get tau is equal to ml square T inverse square. It is also equal to work done as well as energy dimension. Here we will talk about a volume which we already describe it in a very beautiful way. The dimension of volume is equal to length cube, and gravitation constant which we derive from law of gravitation. According to that we use law of gravitation formula, F is equal to gm square or r square. So that is become equal to F is equal to g is equal to f r square or mm. So this equation becomes, so this dimension becomes dimension of force is equal to mlt inverse square, and well, on the same time dimension of mass is m square. So by getting these values we will get m inverse L cube and T inverse square. In next step we will talk about power. Power means work done per unit time. So according to the formula, P is equal to W over T. Putting dimension of work done, that is equal to ml square T inverse square RT. By cutting these values we will get ml square T inverse cube. Next one is a frequency. So frequency is a reciprocal of a time period, and so it becomes a T inverse dimension in a square bracket. Next we will talk about linear momentum. Linear momentum is already described previously, that is equal to P is equal to ml T inverse. And now we will talk about spring constant, which we learn in oscillation. That is, according to this we will use Fick's law, F is equal to Hooke's law, F is equal to kx and x is equal to L. So k is equal to F over L, and basically the dimension of force is equal to mlt inverse square, and our L is represented by capital L. By cutting these we get mt inverse square. The next one we will deal with the coefficient of viscosity. What is viscosity? Viscosity is a frictional part present inside the layer of a fluid, and we will deal it in chapter number 6, but we must know about the dimension of a viscosity. So according to the Stokes formula, F is equal to 6 pi eta RV. Remember one thing, numerical values have no dimension. Here 6 pi having no dimension, or any numerical value having no dimension. So we use eta is equal to F over RV. Now putting these force, radius and velocity values in the form of a dimension, we will get mlt inverse square or L, and dimension of velocity is lt inverse. By cutting these values we will get ml inverse T inverse stress, that is equal to pressure, so force per unit area. So the stress dimension is similar to pressure, so we will get ml inverse or t inverse square. I already solved this example previously, so this was the total article. Today we'll learn about it. Okay, this was the total topic related to dimension analysis, and we'll learn about how to solve, first of all, what are dimensions. Secondly, how to solve dimensions of a different physical quantities, just like force, work done, energy, power, density, up to so on, pressure, stress, volume, area, and up to so on, viscosity. We solve different dimensions. In third step, we learn about that numerical value having no dimension, or a ratio value having no dimension. uh, Dimensions are only just for derived quantities. And in last step, we also learn about how dimensions can solved in by different formulas, and in a different quantities. Okay ji, thank you. And please subscribe my channel, as well as like it and share it with your friends, with your buddies, with your class fellows. Thanks again, and assalamu alaikum, fi imanillah.